I'm going to show you how to add a light into a closet when all you have is one of these. This is the transformer for a doorbell. Close door, please. So in that setup, I used the Norrfly, which is an IKEA made part. And what it does is it has a little sensor right here that when I open and close the door, it turns the light off and on. I set that option there. It runs on 24 volts. And to get this, this is the AC in the house, 120 volts RMS. It goes through, this is a doorbell transformer. This is what you saw up there. And this is pretty standard 18 VAC. Is the standard output of these right here. You can get them in 24, you can get them in multi-taps where they have different ones. Some of the newer stuff, like if you got one of those rings or fancy doorbells, it's gonna add some voltage sometimes. And how it works here is that I bought the device up there is a bridge with a filter cap on the end. And what that does, or smoothing cap, and what that does, it takes the AC and then makes DC out of it. And there's a full bridge and a smoothing cap right there. How it works is we have this originally going in is 120. The transformer will take it down to 18. And then what happens is that it comes up right here, and then when this voltage goes above the voltage output here, it'll then start acting like almost a short, but with a diode drop, the 0.7 volt drop. And then it'll add up here, keep it going. So you'll have this little, this what's called the ripple up and down right there, but it's a pretty good unregulated voltage supply. This is the calculation for right here. This is under load. This is because VRMS, this is for the loaded supply, which means that when it has no load, it'll have a higher output because there's actually resistance that's trying to overcome within the coils. So they rate it a little higher. What you need, I have the 4-watt version in mind, so I need 170 milliamps of power. And when I measured it, this is your equation right here. It gets you 24 volts. However, and this really depends on the input voltage here. So what happens when I have this off, when the door is closed and the lights are off and it's just got the emitter and the detector, the infrared one's going, this actually goes up to 28 volts. I guess it's within tolerance of here. I'd have to rip it apart and tell you what's internal to it, but that's something I'm not going to do. But this is unregulated right here, DC supply. What you can do is you can do what's called a buck boost, and that way you can actually fine tune it for 24, so it'll be much more stable. A buck boost works by cycling on and off a inductor till we get a desired voltage. There's a little bit of ripple in there. This thing can probably handle it, no problem. I just have this set up. I just thought, okay, this should work straight up, and it did. I'll put links to all three different things in there, and for this Norrfly I used. One thing, when you hook up here, make sure to turn off power to your the power, because this, if 18 volts probably won't kill you. They probably put it in there because, like, I don't know the reason why they originally did these. Probably because it's a little safer and it might have gone outside the building envelope, and it would be a little more dangerous to run 120 instead of 18, especially in a wet environment. So I don't know the history of why doorbell have transformers and why the voltage is down. It's safer, but it's best to turn this off. So if you ever do this, decide to turn it off, also your doorbell rating, you might kind of make sure that it's rated properly. Most of them should be, but if you're running other things on there, it might be too much on your system. So if you're running off this, you're running a ring, and you're running this, you might end up, driving this thing too hard. So I don't know, it's up to you to do that right. When you hook this up right here to the little circuit card, these, because of the cyclic nature of AC, it doesn't matter which side is which on this one. However, on this end, this matters. So whatever's the ground is going to be your negative, and usually on the one I have, it's black output for ground and red output outside the circuit card for the positive. And then when I hooked it up to this is the IKEA light bar, they have which is pretty standard for DC devices. You'll have a line or like a solid bar on the ground or whatever is considered 0 voltage DC reference. And then this will be your higher voltage right here. So when you hook this up, this is critical which one you do here and here. I hooked it up like that. It works pretty well. As where I put it inside the, when I screwed it in with this Norrfly, it's got a couple of attachments on there, on the rail that you can install. And when I installed it, I just centered it and I put it right where the stop is. So where the door closes right above it. So that way you got to open it about 6 to 8 inches, and then it's good to go. I hope this works, and it worked in my case where it's an older style house and there's no power in there, but they put the doorbell transformer in there. So it just adds something you can do. Be safe when you're doing this, and hope you good luck. Oh, the other thing I didn't tell you about was the other thing you can do in case you have a transformer that's different output, like 24 volts or 12 volts or a different one, or you have different voltage here, or you're worried about driving this a little high, which you can do that buck boost what I told you about, where the buck boost would be the same thing right here. It's got inputs right here to the AC side, and it's going to have similar outputs usually. Typically it has one output for ground and one output for high. Sometimes they run what's called sense lines, and a sense line is that if you want to read voltage far away, that's beyond the scope of this. But they're going to have on there, it's going to have what's called a potentiometer, and that's a variable resistor. And you're going to use that, and it's usually a little plastic thing. I'll point it out. I'll put it out in a picture. And what you do is you twist it, and then what that does is that varies the output voltage right here. So you're making a voltage reference right here. That way you can set it up to 24 volts and always be pretty close in there. So that's the alternative to that. It's only a couple bucks more than this one is, and if you're not sure, it might be worth it. Thank you.